Hello everyone, and welcome back to Everything Anything Computing. So this is a bonus lesson for learning Android app development with Kotlin language. And the idea behind this lesson is to just give you a basic rundown of what I have covered so far. That is from setting up our environment to learning the basics of Kotlin language and all the way to function. So that's what we've covered from the beginning to where we are so far. And the idea is to clearly explain certain concepts that I felt like I missed a mark or I felt like I didn't explain very clearly. So I just want you to enjoy it. So here we have, as I mentioned, we're going to download certain things. So first we're going to do the IntelliJ, and to just get to IntelliJ, you're just going to go into your browser and just search IntelliJ IDEA. And as I mentioned, IntelliJ IDEA is the integrated development environment, or the text editor that we're going to use. So that's where we're going to write our Kotlin language or give it an input and allow it to give us a sort of output. So to have it, you're just going to go to your browser, type that. It is under JetBrains. So JetBrains is the developer of this IDE, and then it will take you to the part of downloading. So once you type on the browser, you go to download, and then you have two options. So there's one that is paid, and then there's one that is community edition. I urge you to download the community edition, which is basically it contains everything that we need, so we don't need to pay for it. So for the paid, it will have more functionalities that this other one doesn't, but for now, what we are trying to achieve, this is enough. And then after that, you're going to go to the JDK. So the Java development kit usually is hosted on Oracle, and then you just go to that, and then from here you can pick which version you want. So normally you if you listen to many programmers, they'll tell you to pick the version just below, because it means that it has gone through so many updates, so many upgrades as compared to the latest one, and it matches everything in terms of with your IDE and so on and so forth. But usually I install the latest version, and then yeah, that's what I usually do. And then remember your operating system, pick the right operating system. So for mine, I'll pick the Windows, and then you can just download the installer. And then once you download the installer, all you need to do is now search. So once you download it, just search. So you can actually download this here, or once you download your IntelliJ IDEA, when you're installing, you can actually decide to download, or when you're creating your first project, you can decide to download the actual JDK that you need. So for me, I have downloaded this thing so many times. I have installed them. If you need to see me showing you the different installation process, it is still in my different courses platform, so you can just go there and see what I've done so far. So we'll just go ahead and open IntelliJ for now. And as you see, I have the community edition. Okay, so in this, the first one that we are doing is this is something I have been working on with you guys from when we started. So what I'll just do for this lesson, I'll just create a whole different project. And this is how we created a project, as I mentioned. So new, and then give it a name. So I could call it Kotlin Basics bonus lesson, because I know I created something called Kotlin Basics. And then this is the location where you want this project to be stored. I'll just leave it as the default. For now, we won't talk about Git. We'll talk about Git mostly when we get to use Android Studio, and Android Studio is the main IDE that you're going to use in terms of mobile development. So this one is just for us to understand the Kotlin language itself, the basic syntax, the semantics, what it entails, and so on and so forth. And then when we get to Android Studio is when now we're actually developing the actual environment. And then this is the build system. What build system do you want to have? For now, these are usually more they have more functionalities in terms of the build, so you can use it when you're developing bigger projects and so on and so forth. So for now, we're just going to use the IntelliJ build. And then, as I mentioned, you can install you can download your JDK on the browser and then have it selected here, because I already downloaded it and installed it, I can have it here. Or if you haven't downloaded it from the browser, you can just come here and download the JDK, and then it will give you the different options. So if you click on this, it gives you which version do you want, so you can pick on the version and so on and so forth. Depending on what you want, you can pick what you need for now. But as I mentioned, I always pick the version that is the latest one. So for me, it's usually version 24. So once you do that, and I mentioned the JDK is to translate your code and then add sample code. But for now, I won't add any sample code. We will create our own code and then we will just do create. Yes, I just want it on this window. So yeah, so now we have our IntelliJ IDEA, and this is how it usually looks like. And this is the text editor that we're going to focus on. But the main, but before we get into now coding, I just want you to understand the different parts of the editor. And we have here a side panel on this side. We have a top bar panel. We also have a project panel on this side here. And what we are going to focus on, this is where our project structure is. And one thing you need to understand about programming is just basically files with different extensions depending on the language that you're using. So like right now, when we are learning about in Kotlin, our extension files will be .kt. And how to create our files, we're just going to use our source folder, and then under main or Kotlin, we're going to create a new file, and that file is going to be you just pick Kotlin or class, and make sure you pick on file, give it a name. So let's just start from here to understand what is going on. So with Kotlin, the entry point when you're using IntelliJ is the function main, and you will learn more about functions in this lesson as we move forward. But what happens is normally there are certain keywords that the compiler looks into, and the compiler, you'll also understand what a compiler is, but basically the compiler is what actually builds, or you could say what compiles your language and translate it into something the machine understands, and then gives an output based on what you had given as input. So for the compiler, it needs to understand the different keywords. And that is the whole idea about languages or Kotlin language. It has different keywords, and the keywords are understandable to the compiler. And the compiler is what translates your high-level language to low-level language. And low-level language is the machine language. High-level language is this language that is almost readable to human eyes. Actually, it is readable to human eyes, but it cannot be readable to the machine eyes. And what happens is it needs to have an entry point, a start point, a file that whenever it comes up with, this is the file that starts running, or this is the function that starts running. So to do that, usually here we have a function called main, and this function main is the entry point of our programming language in terms of Kotlin in this case. So immediately it sees main, fun main, and because our file is called main, it knows that this is the entry point of our program. And when you it ensures that now you can actually give it an input. And in this case, you're just telling the program that we want to print a line that says hello on our console. And you can see here on our console, it actually printed hello world. So that's basically what is happening here. So one thing I want to emphasize is the idea of you need to understand that Kotlin language is all about or rather programming is all about keywords and the right syntaxes. One thing you need to know is if I remove the closing brackets here, you'll see that we'll have an error here. and the error is just telling you clearly it is expecting a closing bracket. And you can see the only reason it can do this is because it has the JDK here, and the JDK allows us to have all the tools that we need when we're writing our Kotlin language. So you can close it. And then another thing you need to know is if we remove this function and call it something else, maybe function run, you can see we no longer have a run button here. We cannot run this application because the keyword or our compiler does not know where to start in terms of running our application. So if it needs that keyword main to know that, okay, this is the starting point of running our application. So we can write any other thing anywhere. And then if it is linked to this file and we have this function called main, then our application will actually run. So this is our first application. And I'm gonna see you in the next lesson. Okay, so in this section, we are going to now go into something called the variables. So we're gonna do this very fast because these are things we have learned, but I just wanna explain them better. And basically in variables, we say that variables are container. So one other thing I usually like to emphasize when it comes to programming is the idea of data. So the whole idea of programming is how are we going to store our data? How are we going to reference our data? How are we going to manipulate our data? How are we going to communicate the data and so on and so forth? And because it's all about data, then we need to be able to store that data. So you can think of variables as the building blocks of programming in a sense, because it is where you start in terms of storing a reference point or storing a value within your application and using that storage or that memory allocation, calling it and making something out of it. So for you to be able to create a variable, we need also the keywords, as I mentioned. So there are two ways you can create a variable. So you can use the keyword var or the keyword val. So those are the two ways in which you can create your variable. So in this case, we can start with var, and var, you give it a name. So the name here is called first name. We can think of it in terms of first name, and then is equals to, and then you can say Salome. Salome, my name, that is. So here you can see one of the things I didn't mention in some of the lessons that I was teaching is the idea of naming. So there's the best practices in terms of programming. So how is the best way of naming your different variables or different files and so on and so forth in Kotlin? And normally when you're naming your variables and it is more than one word or two words, just so that it is very much readable, you can use camel case-wise naming, where you have the first name in small letter and every other preceding name in capital letter, or you can use the Pascal ways, which is basically the first name in the first all the first names of your application should be capital letters. So you can use anyway so that it is very readable in human eye. Immediately I see it, I know what is happening. So in this case, this is you're basically telling your compiler, I want a memory allocation. That memory allocation is called first name, and inside that memory allocation, I have a value called Salome, which is basically a string format. So that's what you're just telling your application. And every time you want to your compiler, sorry, and every time you want to reference this value, or you want to make edits in this value, or you want to change this value, or you want to change the actual memory allocation and so on and so forth, you need to use this name of that memory allocation to make any change for that memory. So this is just basically you're telling the compiler, hey, I need a memory, and that memory, I'm gonna call it first name, and inside that memory, I want to put in a value. So you can use that. And one thing you need to know now is this, if you use the keyword var, you can actually change that memory. But if you use the keyword val, so in this case, you can say second name. So for me, you'll see me switching between Pascal wise or camel case. Either way, there's still, provided you use something that is readable. So in this case, I have second name that is, I could say Monte. So we have our second name, which is Monte, yeah. And what happens here is, if you try to say second name is equals to Lucy, we can actually remove this and have all this in our main function. So if you say second name, and you can see now that it is in our main function, we get things like autocomplete. It notices that there's a variable that I already called second name here, and then you give it something like Lucy, you actually get an error and it tells you val cannot be reassigned. So meaning the memory allocation that is allocated using the keyword val cannot be reassigned. But if I change this and say first name is equals to Lucy, and ensure that because it is also case sensitive. So if you used capital letter and you use a small letter, then it is, the compiler thinks of it as different variables. So you always need to ensure that you check on the camel case. And you can see here, this has no error, and you can actually print line first name. So when you run this, you will actually see on the console, it will print the name Lucy instead of Salome because it was changed. As you can see here, it prints Lucy. But if you remove this Lucy and run this, it will actually print Salome now. So one thing you also need to note now is that the compiler runs your code from top to bottom. So from this first code to the second code and so on and so forth. And that is why when you change this to Lucy, it picked the second line as opposed to the first one. So that's one of the things you also need to think about and to remember. So that's just what basically variables are. And as I mentioned, they're just a memory allocation, and in that memory you have a value. And now every time you want to manipulate that value or you want to change the memory allocation to read something else, you need to use the name of that variable for you to access it. Okay, so now we can go to something different, which is called the data types. And basically, one thing you need to know is, as I mentioned, programming is about data. So you need to know that data is not always the same. We have data that is in number format. We have data that is in string format, which is just basically text. We have data that is either a true or false value. You can just have data that just stores whatever you said was true or false. It's called a Boolean value. And then you can have data that stores decimal points, float, and so on and so forth. So you need to understand these different types of data so that whenever you are creating your variable, it follows that structure. Your compiler knows that this, whatever you created, is a text, or this, whatever you want to create, is a Boolean, and so on and so forth. And you will notice as we move forward, there are certain places where you will definitely need to explicitly state that this type of data that I'm creating is a string, and there are certain places that you do not need to do that, and that is called something called a type inference. So let me just show you what I mean. So right now we can create a variable. If we go back to what we have been referencing so far about the idea of tenant or rental management system, we can have a variable of tenant name. So tenant name is equals to Salome. Now, if you want to explicitly tell your compiler that this is a string, or rather this is a text, you need to put that column there and then write string. So automatically your compiler knows that this variable that you declared here is a string. And what a string is just basically it is text. But one thing you've noticed is that even if we don't declare it here, it can tell that this was a string based on the opening and closing quotes after the assignment operator, which is the equal sign. So that closing and opening and closing quote, the compiler can infer that this is actually a string or this is actually a text, and so on and so forth. So that's something called the type inference. So where you don't have to explicitly say that this is a string or this is a number. Another thing, another type is called, you can have variable unit number is equals to 1. So whenever it sees this, the compiler can infer that this is an integer, or rather this is a whole number. But if you want to explicitly say that this is actually a whole number, you can use the int keyword. So this int keyword basically tells your compiler that this is an integer, and an integer is just a keyword for whole number. This is a memory allocation that stores whole numbers only. And one thing you'll notice as we move forward, I'll show you certain things that you cannot do. You cannot, once you've declared that our memory only stores whole number, you won't be able to store decimal numbers, and you'll see that shortly. And then we have variable. You can have unit amount. So what amount is being paid. You can have it as a double. So what a double does is, a double is another type of data in Kotlin that stores decimal numbers. So as you can see here, we have an error. And if you look at that error, it tells you to change to 1.0 because it needs it to be a double. Because you've told your compiler that in this memory allocation, I'm only storing numbers that are double. And then when you move forward, you can have a variable that actually check payment. And if you check payment, this one can actually can return true. So what happens here is, this is a variable that stores a Boolean value. It either checks if it is a false or true based on certain conditions. And you will see that it is mostly used in terms of conditional statements when we move forward. So here it checks, is this memory allocation pointing to a value that is true, or is this memory allocation pointing to a value that is false based on maybe a condition that you gave it? And in this case, because you've automatically assigned it to true, then every time you call check payment and you run it, it will return true, because the check payment was assigned to a value true. So whatever the memory allocation you gave it here should be true. And for you to explicitly, so you can have type inference, and type inference is just basically, it knows, your compiler knows if anything is assigned to either true or false, then it becomes a Boolean value. But you can have it here and give it Boolean value. So this, your compiler knows that whatever it is that you're creating here is a Boolean value. And if you try to have it any other way, it will give you an error, because it tells you, if you show the concept, this is check type of check payment to int, because you've given it a whole number. It's no longer a Boolean value. So those are those are some of the data types that we're going to look into. So integer, double, Boolean values, string, and this is a string, as we mentioned. We can have it back here. We can have it as a string, and so on and so forth. So one thing you need to know when you have to explicitly say the type of data that you have, or when you do not need, when you think about your compiler can easily infer and know what type of data that I have here. So these are the types of data that we have. And then another thing you need to know that is, in terms of integer, there are certain limits within your integer values. You can have, I think to look at the integer value is int dot maximum value. So here what happens is, you have the unit number. If you check at the unit number, so there's usually ranges. So as I mentioned, this is something to do with memory allocation. So memory allocation usually has a size, yeah? So when you're storing values like integers, when you're storing values like strings and so on and so forth, usually it has a maximum size you cannot go after. So in this case, if you look at unit number and you look at the maximum value, so int dot maximum value, it will tell you what is the maximum value that the integer can actually accept. And when you run this, you will see it only accepts a value of, what is this value? 21, 47, 48. This is the maximum value that it can accept. And if you take that value and give it any value after that, let's say that, you see you have an error. And the error basically says that the unit type is actually too big. So you can turn it to something called a long. So a long is also another type of another type of data type that allows you to store bigger value of numbers. So if you look at the maximum value of long, so that is long dot maximum value, and you run this, you will notice that the long is longer than the integer that you had. So int stores smaller values of whole numbers, long stores bigger values of whole numbers, and so on and so forth. So it is important for you to know this just in case you want to store something bigger than what you already have. But the common type of type data type that we use in terms of storing whole number is usually int. So it is very rare you find yourself using long, but when you do need to use long, now you know how to find it. Or you can also have byte. That's another type of whole number storage that is usually smaller. So these are just different things you need to think or to have in mind to know that there's a limit size in terms of your memory allocation. Okay, so now that we've learned about data types, we can just go back to our notes and see what we are going to look into next. So we can look into something called the operators. And under operators, there are three main things we need to look at. So there's basic mathematical operators, there's comparison operators, and there's logical operators. So mathematical operators, so here let's just do this math operators. Okay. So mathematical operators are just basically what we have been learning in math. If you think about your calculator, what are the different mathematical operators that you need in terms of adding, in terms of subtracting, in terms of checking our reminders, in terms of a division, multiplication, and so on and so forth. So it's usually something like plus, minus, multiplication, this is you use the asterisk, division you use the forward slash, and then there's something called the modulus, and modulus basically just shows you what is the remainder of a specific number, and so on and so forth. So modulus is like if you have like a number like 5 divided by 2, what will be the remainder? So 5 divided by 2 is 2, remainder 1. So the modulus gives you that remainder. So I'll just show those things in action right now. So right now we have a person who is paying, let's say, 100 or 200.0. We have that is the unit amount. And in our house, we can check at variable number of tenants. So what number of tenants we'll just check. So let me just have this here so that you don't get confused. We can leave that. We can go back here so that you don't get confused. Okay, so here we are going to look at that. We are going to look at, we're going to take this and look at that. So we have a variable of unit amount 200, or we can have so we can have, so we want to start with first operator, which is addition. So we can have tenant 1 unit amount is 200. We can remove the double and it will infer, our compiler will just infer. We can have tenant 2, and then we can have variable total amount, which will be equal to this plus this. So basically what we are saying here is We have two variables of tenant 1 and tenant 2, which one pays 300, another one pays 200. So I want to reference both of them and add them and store them now in a different variable or memory allocation that calls total amount. So I can actually now print line total amount. So when you actually run this, you will notice that it will print the total amount, which is 300 plus 200, which will be 500. I think there's something else we are printing here. For now, we can just comment that out. Just remove it. Yeah, so it is printing 500. And then if you want it to be more explainable, you can actually have now a string, which says the total rent is equal to, and then have your column. And then what happens, so that you break and tell your compiler that this value here that I'm actually referencing is no longer a string, but it is actually a variable that I want to access. You can use now a $sign. Sorry, a $sign. So this $sign breaks that sequence and tells your compiler, okay, I'm escaping now from what we were actually doing in terms of string, and I want now to come out of it and reference an actual variable, which is this. So now when you run, it gives you more information. So it tells you the total rent amount is equals to 500. Now you know what it's actually doing. And it actually took tenant 1, the variable tenant 1, the variable of tenant 2, and added them and gave you the total amount. Now, if you want to do multiplication, say you don't want to actually make, what is it called? Have to add each and every tenant that you have. You can have another variable total tenants is equals to 3. So you can have total tenants that pay 200. All of them pay 200. So here you can have something like total tenants that are equals to 3, and all of the 3 pay 200. So for you to use the multiplication, you can actually just basically do variable total amount paying 300 is equals to, then you will take the total tenants, and then what you will use the asterisk. So asterisk, so that is basically multiplication multiplied by total tenant to unit amount. So now you see you have a variable that says total amount paying 300 is equals to this. You can have a print line that says the total rent of people paying 300 is equal to, and then this time you actually call total amount paying 300. So this is actually important if you think about it logically. When you have some houses, some units might pay higher and some units might pay lower, but some units might pay higher, but not only one unit, maybe 3, 4, and so on and so forth. So now you can have this clearly explained in your application. So when you run this, you will see the explanation on your console. So the total rent amount will be now 600 because there are 3 tenants all paying 200. And then if you want to look at subtraction, it's the same thing now. If you take tenant 1 minus tenant 2, it will give you what the value that tenant 1 is paying more than tenant 2. So if maybe you want to know which tenant is paying more and at what amount is the tenant paying more, you can use subtraction. And then you can have something called the division. So division basically is if you want to divide, and maybe you have now you are trying to maintain your house, and once you're trying to maintain your houses, you're calling maybe a carpenter, and the carpenter is charging for each house, for each like for the total amount he is charging, let's say 500, and you only have 5 houses. It means that for each house he is charging 5 shillings, 100 actually. So what happens is, let's say you have variable maintenance funds is equals to 500. So this is the total charge your maintenance is actually costing. And then you want to look at number of houses, variable number of houses. I am doing this so that you know that programming is actually something logical. You use it to accomplish specific problems. That's the whole idea of programming. So here in this case, we have number of houses is 5. And then you want to check what was the charge for each house. So to check what was the charge for each house, you say variable charge for each house. And then another thing you need to know is when you're naming your variables, always make sure they're very self-explanatory. You don't have to explain to anyone, or the person reading your code won't be confused. And that's the whole idea of programming, is because you will always work with people in terms of programming. So in this case, now you have number charge for house is equals to maintenance divided by house. And when you do that, and then you come here, and then you do the total charge per house is equal. And then here, instead of referencing this, obviously we'll change our reference to charge for each house. And when you run this, you will know the charge for each house that this carpenter actually charged you. So here you will know that the total charge per house, and it garbage in, garbage out. That's one thing you need to know. So the total charge per house is equals to 100, meaning that for each house that was repaired, the carpenter charged 500 or 100. But sometimes you can have a charge that maybe does not actually add up to equally, like it was not split equally among the houses. Let's say we only had 4 houses, meaning that does not split it equally. You'll have like 0.000. So you want to see what was the remainder after each house was charged as a specific amount. You can now use the modulus. So this modulus just gives you the actual remainder of the value. So now you see here that the total charge per hour per house is equals to 0. So what you can do to ensure that it actually gives us the remainder, you can use a double. And here a double. Okay, so for the okay, so that doesn't give us any reminder. So let's try 3. And you can see here there's a remainder of 2, as you can see here. So that's the whole idea of modulus, and it just basically shows you the remainder after division. What was the remainder after division? Okay, so now we have that. We can go to our next part. Or another example is if you want to see if the numbers are either prime or even, and so on and so forth. So you know that even numbers are usually, or prime numbers, or actually odd numbers are not, they are not divisible by 2. They usually have a remainder. So you can have a variable that stores number, let's say odd number, which is equals to 5. And then you can have now the variable that check if odd is equals to 5 odd number. So reference the variable. So odd number modulus 2. So if this gives us a modulus, then it means that this is not an even number. So if you check, if you do print line, check if odd, if it gives us a value, then it means that whatever it was that was there is not an even number. And you can see this one gave us 1, so meaning this number is not an even number. Or you can even have this as check number. And then what happens with check number is, I want us to name it the right way so that we know what we're doing. We're just checking if the number is an even number. So here is the number even $. And because it gives us a modulus 1, then it means that this is not an even number. So this is not an even number. But if you have a 4, and you'll see this in conditional, how it will become so important. Now this one, you know for a fact that this is an even number, because if you check the number modulus 2, it gives you a 0. But any number modulus 2 and gives you a remainder, it means that that number is not an even number. Okay, we can move forward on our list. And on our list, we're just going to look at something called, so this is just basic math operators. Now we're going to look at something called the comparison operators. And basically comparison operators, just like the name says, is when you're trying to look into comparing one or more thing, yeah? You can have less than, you can have greater than, and then you can have not equal to. So those are the different comparison operators that are there. So it just checks, is one memory allocation equals to the other memory allocation? Is this memory allocation less than this memory allocation? Is it greater than this, or is it not equal to this? Then if it is not, print this, and so on and so forth. So it's mostly you can mostly use it in conditional statement. For now, I'll just mention them, but you'll see them in action when we are starting to do like if else statements and so on and so forth. Another type of operators are the logical operators. So these are the and, we have the or, and we have the not. Basically, what this do is allow you to come up with a specific logic. And that logic might include, if this and this are the same, or if this and this, if this condition and this second condition are both met, then do something. So that's the whole point. So what happens is, especially with something like and, is if you have one condition and you have another condition, provided both of them are true, then it returns a true. So if it is 1 and 1, so that is true and true, it returns a true. But if it is 0 and 1, it returns 0. And if it is 1 and 0, it returns 0. So for it to be satisfied correctly, both conditions must be true. If either one of the conditions is false, then it returns a false. So that's the and. And then the or, either one of the condition could be true, or all the condition could be true, then it will produce a true. So if it is 1 and 1, it produces 1, 0 and 1 produces 1, 1 and 0, it produces 1. Only when 0 and 0, then it produces a false. So for it to produce a false, all of them have to be false in terms of or. And then not, what not does, it just basically negates a condition that was true. So if it is 1, then the condition becomes 0. And if it is 0, then the condition becomes 1. So 1 and 0s here, I'm just using 1s and 0s to represent a true or false value. So if it is true, the not, if you put this keyword, or you can say this this sign in front of a value, then it changes it to false. So now for us to understand this more, we're just going to go to conditional statements. And the first conditional statement that we're going to look at is the if-else statement. So in this case, maybe you want to check if a person is, you have an age. Let's say you want to rent out to a person, and you obviously, when you're renting out to a person, you need to look at their age, you need to look at their bank account. Or they not some people actually look at people's bank account to just see if, or work or so on and so forth, and just see if this person is actually eligible to pay, or will he be a stubborn tenant, and so on and so forth. So you can look at the age to ensure that you're only renting out or leasing your property to a person who is of the right age. Let's say we have variable age of tenant is equals to 20. For this case, he is 20. However, we want a condition that checks if the age is actually less than or equals, or so that's where we are going into the idea of comparison operators. So these are the comparison operators. These were the logical operators. So we're going to start first with comparison operators. So for comparison operators, we want to check if the age of our tenant is appropriate age. So how we're going to do it, you're going to use something called the conditionals. So in programming, one of the most important things to do is, now that we've understood how to store data, we've understood that there are different types of data and so on and so forth, we've understood that you can use programming as a calculator, we need to have something called conditionals. We need to now give our program some logic of some sense. We need to give it, if this is true of this, or this is wrong, I want you to give me certain outputs, or I want you to do this for me. So that's that is actually the basic idea of programming. If you think about it, you want to instruct it based on a condition that you have. So let's say if age of tenant equals 18, print line so if is written like this, open and close, yeah. So print line, the tenant is eligible. So in this case, when you run this, nothing will be printed. And the reason as to why nothing is printed, because the age of the tenant that we have here is 20. But let's change it to 18, and then you'll see. You can see here the tenant is eligible. But now this is very restrictive. We only have if age of tenant is equals to 18, then do this. What if we want to say if age of tenant is less than 18, then the tenant is not eligible. So right now, nothing is printed because the tenant is actually 18. So one thing you need to know with terms of if else, if condition is, this is the first condition, which is just if. It's very restrictive to only one condition, but you can have actually more condition. Let's say else. Else, you can have age of tenant greater than 18, open and close. So this is the logic of writing your, let's just check what the error is. Okay, so this is else if. Else if, age of tenant. So there's the if, else if, and finally the else we will see later on. So that's what I had confused there. So else if age of tenant is greater than 19, then print tenant is eligible. So in this case, you will notice that we will have the tenant is eligible. Or in this case, we don't even have anything, because here we only have equals to and not either greater than or equals to. So if you change this maybe to 20 and run this, you will notice now that the tenant is eligible. However, you can have an else statement, an else, and then print this value is not specified. So now when you run, and maybe you can have here as 18, you can have this as 18. You will notice that the thing that is going to be printed is this value is not specified, as you can see here. So the different comparison operators allows you to do all these things. And then another thing is you can have actually less than or equal to. So now if it is less than or equal to, then print the tenant is not eligible. The tenant is not eligible, as you can see. So that's the idea of all the comparison operators that we can have. And this is the else, if else statement. And then finally, you can have now the idea of logical operators. And here, as I told you, it looks at two conditions. And in this case, we can have if age of tenant is less than or equal to 18 and no ID. So here in this case, we can have a variable that says no ID returns true. Yeah. So here we have a less than equals to 18 and no ID, then the tenant is not eligible. You can be less or equal to 18, but you can have less than equal to 17 actually, and no ID, then the tenant is not eligible. However, if the age of tenant is greater or equals to 18 and no ID, then the tenant is not eligible, So here, if the thing is false or so on and so you'll see what will happen if I change the different outputs. So now when you run, you will notice that it will print the tenant is not eligible. Actually, is eligible. Let's just do here and ID so that it makes sense. Or holds ID and holds ID and holds ID. Holds ID. So now when you print this, you will notice that it will print the tenant is eligible. As you can see, the tenant is eligible because this tenant satisfies both of these things. He has an ID, yes. Is he 18? Yes. What if we have here a false? What will be printed? It will be printed as the value is not specified. The value is not specified because, first of all, he doesn't meet this condition. He is not less than 18. He's actually 18. And he doesn't meet condition, but he meets this condition and so on and so forth. So that's the main idea of having our logical operators. But you can also change this and have it as or. So or allows you to have either or one of them become true. So in this case, we have a false. We have he does not hold an ID, but he is 18. So when you print this, it will tell you the tenant is not actually not specified. Let's see. Oh, this is less than or equal to, okay, so this should be greater than or equal to 18, or it will print the tenant is eligible. As you can see here, the tenant is eligible because the tenant satisfies one of this condition, which is he is 18 but does not have an ID, and so on and so forth. So you can see how these things actually happen. And then here, if you actually have a not, yeah, or here if you actually have a not, now you will see that it will print the value is not specified. The not, what happens is it negates. If it was a false, it gives it a true. So when you run this, it will still print the tenant is not eligible. And the reason as to why it printed the tenant is not eligible is because we have a true value here and we have a more than, so it is true, and one of these conditions is actually met, and the condition that is met, it is this one, which is true. So the condition true was met, but this condition is not met because he is 18 and above. However, it will print this because one condition was met. And as I told you, when you're running your compiler runs from top to bottom. So because this is our first one, even though it actually also meets this condition, it also meets this condition. It meets more than one condition. So it will print the first one. So that is, I've combined if, logical comparison, and so on and so forth. So another thing we're going to look at is something called before we finish, before we go to the next class, in the next class, actually, I will combine list and arrays, null, safety, and finally functions. So those three. But for now, this is what we have a bonus class for. And thank you for joining me. And I'll see you in the next class of our bonus class. Go to explaining a for loop. So I had actually recorded this initially, and I just realized that I wasn't sharing my screen. So that just took me off a little, but we will actually do it again with you guys. I'll do it again with you guys. Okay, so let me just confirm everything is working. Okay, I think everything is working. Okay, so let's begin. Let's just go to the for loop. And what I was explaining in a for loop is you want to do something repetitively. And I gave an example of you have your properties and you want them to be clean. Each property you want it to be cleaned, and if cleaned, you want your system to say house 1 was cleaned, house 2 was cleaned, and so on and so forth, repetitively after every hour, or so on and so forth. So what happens if initially you'd have 8 variables for all the houses that you have? Let's say you have 10, you'll have to create 10 variables for all the houses that you have. And yeah, clean, and so on and so forth. But you can use a for loop. And what a for loop basically does, it's a loop that repeats a certain condition, provided whatever it is that you want it to do is within the condition you want it to complete. In this case, you have a variable called clean house. And in clean house, in this for loop, the clean house is in the range of 1 to 10. So it's supposed to repeat 10 times. In that, it's supposed to send a notification that the house was clean 10 times because you have 10 houses. So here it prints the line house is clean house number, and then it calls the variable which is clean house. So now when you run this for loop, when you run this, you'll see here that this condition was done 10 times. Another thing you can use it for is maybe you want to send a tenant reminder. So you can have for, and then inside is tenant reminder in a range of maybe 1 to 5. Maybe you want it to do after repeat after every 10 days, or repeat after every 5 days. Yeah. And then you want it to print line, please clear your rent balance. So what happens with this is it will send out this, it will print this thing 5 times because you have given it a range of between 1 to 5. So when you run this, you see here that we have something called, it says, please clear your rent balance, please clear rent balance, please clear rent balance. So what happens is it just checks for tenant reminders in a range of 1 to 5, then print a balance. You can also have the tenant reminder in and then put dates, the date between this date and this date, then continuously send reminder. So the range can be, or your condition can be specific to what you want to achieve. In this case, I was just doing a simple one that just prints something 5 times. So that is our loop. And then finally, we went into something called the null safety. And I really wanted to explain this null safety issue. So I'll just do this all over again. As I mentioned, I had been doing this, but I wasn't recording my screen, so everything was lost. So anyway, we do it again. So null safety is when you're creating a variable, we say that programming everything is in relation to data. So storing your data and so on and so forth. So when you're creating your variable, you're talking about a memory allocation and memory allocation for a specific value. And you know in terms of let's say initially when you're creating your registration, you don't have to include all your personal details. But later on, when you say update profile, you can include your ID and so on and so forth. So initially, when you create, maybe you don't want to include you don't want to ask your user to key in their national ID card. But when you tell them update profile, they can actually add things like the ID and so on and so forth. So initially, it will be null, but later on, it can get a value. So in this case, how to do it is you will use specific sign that will allow your compiler to know that, okay, this variable has been created, but for now, it is actually going to be null. So let me just show what that happens. You create a variable, say var ID number. Now, you remember when I talked about the idea of explicitly stating the data type. This is one of the times you need to explicitly state the data type, especially if you're going to declare a null value. It has to be declared initially, explicitly told that this variable is going to be of string or an integer and so on and so forth. So in this case, it's actually going to be an integer. And then you're going to give now this sign, this question mark, this question mark now is what allows your compiler to know that this variable is going to be null. And this is the word for null, for it to be null. So if it basically just says I have created a variable or I've created a memory space, and the memory space right now is just empty. So if you remove this question mark, you will see that we will have an error. And when you go back and read the error, it says null cannot be of a value of none, null type int. So it means that because you declare this as an integer, it has to have a value of an integer, either 2, either 3, and so on and so forth. But you don't want it, because you want it to be empty, you need to tell your compiler, this is going to be null for now, safely. You're telling it safely, I know I am the one who declared this variable, and I want it to be null for now. And then now, there's something called an Elvis operator that you use with null safety. And what the Elvis operator does is, now that you know initially it was empty, sometimes you don't want when you're calling it to just print an empty value. Maybe you want it to tell the user, so far, the user hasn't inputted their ID, or you want to prompt the user, please, you can go ahead and input your ID now. You can use something called the Elvis operator, and I'll just show you what that does. So var my ID number is equals to, and then you're going to refer to this variable here. So is equals to ID to ID number. So right now, the ID number is empty. When you run this, when you say print line my ID number, it is just going to be an empty, nothing is going to be outputted because it's just empty, yeah? The variable was empty, nothing, it just says null, yeah? So now, what if you want it, instead of saying null, you want it to give it a sort of default value? So the default value, you use the Elvis operator, which is basically a question mark and the colon, and you tell it, now, if it is empty or if it is null, print the user has not inputted an ID number. So now when you run this, instead of printing null, it prints the user has not inputted an ID number. Garbage in, garbage out. So let's just run that again. The user has not inputted an ID number. Now, if you actually give it an ID number, let's just say this is my ID number, and then now you run it, you will see the output now becomes 3, 4, 5, 6. So this is the main value. But if the value is initialized to null, then it gives it a default value of this. And the only way it can do that is by using an Elvis operator. This is called an Elvis operator. And then this is called the null safety. So this question mark allows it to tell your compiler, this for now is going to be null, or it's going to have a value depending on what you want to achieve as the programmer. So this was just an example I did before I realized I was not sharing my screen. And this is just for email. And right now it is example at email. If you don't have an email, if it's just null, it tells you that the email is now null. But if you have an email, it will print the email, and you can see here it printed the email. So now we were just talking about the list and arrays. And list and arrays basically is you want to have a list of the same type of data ordered in a specific way in the same variable. So right now, maybe you have properties, and each property has different type of tenants, and you want to store all the names of your tenants. You'll have to create a variable for each tenant name. However, you can create one variable, and in that one variable, it can store all the names of the tenants in a keyword called list of. So let me just show you what that is. So variable tenant names is equals to, and then you use the list of. This allows you to explicitly say the string, but you don't have to do it because I told you it can infer. And then now write the different names, Amina. So you separate them with a comma. This is the syntax of writing a list of Caro, Salome, and Noel. This is now the way of writing it, yeah? But you can always this is the actual syntax of writing it. And if you do not follow the syntax, let's say if you just do like that, it gives you an error. If you do not separate them by a comma, it gives you, if you remove that, it gives you an error. If you don't separate them by a comma, it also gives you an error. So to separate the list, you have to separate them by a comma. Depending on the type, if it is string, obviously opening and closing marks, quotation mark, opening and closing quote marks for the string that you want to store. So now when you do print line, and then you call the variable, which is tenant names, and when you print, it's going to output all the names of your tenant. In this case, it is Amina, Caro, Salome, and Noela. So those are all the list of your tenants. Now, one thing you need to note is I said it's an ordered type of variable or list. So what happens is right now, if you want to access the value of Amina, it is usually indexed. They're usually indexed from either to access a value, you have to know the index of that value, or rather the position of that value in your list. So it is a container that is stacked in a sort of indexing. So here it starts from 0, and then 1, 2, 3, and then and so on and so forth. So if you want to access Noela, you do not access 1, 2, 3, 4, but you access index 3, because the indexing starts from index 0. So position 0 all the way to the last position. So like right now, if you just want to access the first position of your element, you use 0. And when you run this, you get Amina here, as you can see. So that's the whole point of positioning and indexing. And then another thing is just like variables and the keywords for variables, that is var and val, there's a way in which you can create a list that is ordered, that is mutable and immutable. So in this case, if you want to maybe add a tenant, so tenant names dot add, and then you want to add sister, let's say sister. Right now it gives you an error, and the error says that this reference is not known. It has unresolved reference add. But if you change this now to a mutable list of, you can see that how is the keyword written? Okay, so now if you change this into mutable list of, you can see that you have the error has disappeared because this one is mutable. This is a list that is mutable. And when you run this, and remove just the position and run this, you will notice that our list will add sister in it. And you can see here, initially it ended as Noella, but now it has added sister. So one thing you need to know is that there are some lists that are mutable and some lists that are unmutable. So if you want to use a mutable list, you use a mutable list of as the keyword. But if you just want to use a list of that, you know that this will never change, like let's say your property, you know for a fact your property has only 10 units and it will never change, you can use a list of. Another way of declaring lists is using array of. So let's say like the idea of property units is equals to array of. So array of actually allows you to create these things and to explicitly you explicitly know the number of units that you already have, and it does not change. Also array of does not change, just like list of unit 2 and so on and so forth. So this is another way of declaring lists within your application. So yeah, so that is what I wanted to take you through in terms of lists and arrays. And then when we learn functions, you will see that there are some functions that can be used with our arrays. So let's just go straight to functions. And what are functions? Functions are a block of code that can be called to do a specific task that is not repetitive. Yeah. So sometimes you want to, maybe you want to send, like one of the examples we had here was sending a reminder. So you can just always call a function, and the function, what the function does is just to send a reminder, That's all it does. So you don't have, every time you want to write a reminder, you have to go back and do the same things again and again. Let me just give you an example of, think about a tenant with a letter. And that letter, you use that letter to, like a contract letter. When every time you get a tenant to, you want to list a property to your tenants, you give them a contract. So you usually do not always create new contracts every time a tenant comes. You just have a template with it. You have specific patterns, maybe the name, the unit number, the price, and so on and so forth. So that, think about that. That can be a good example or a good comparison to what a function does. So you have a template, and then all you need to do is just call that template when you need it, and just change specific things within your template to suit what you want at that specific time. Let's just say here an example is, you want to have a function that will always calculate the tenant amount, the total tenant rent that you have. So what you do is, to create a function, you have to use the keyword fun. As I told you, there, because this is a language, there are certain keywords that the compiler sees and automatically knows that what you want to achieve is a function, or what you want to declare is a variable, and so on and so forth. So you just create a function, give it a name, say calculate rent is equals to, sorry, not is equals to, and then open and closing bracket. So the function itself, the syntax of the function itself is usually the keyword fun, the name of the function, the opening and closing bracket of the function, and then opening and closing curly brackets of the function. And this is where our body of the function lies here. This is where the body of the function lies. And then here you can have things called parameters, and you will learn that as we move on. So here we have a function that calculates the rent. And basically what it does is it prints it says, please key in the amounts. So it prompts you to key in the amounts for now because we do not have any amounts as of now. Yeah. So what you do is now when you want to actually call this function, because right now when you run it, nothing happens, nothing is outputted. So for you to call this function, you need to call it and write the name of the actual function, which is calculate rent. And then when you run this now, you'll see, please key in the amount for me. Maybe you can make it even more wiser for me to calculate the rent. For now, that is all it does. We have a function that calculates rents, and basically what it does, it just tells you, please key in the amounts for me to calculate the rent. So this is the basic syntax of our function. You usually have the keyword fun, the name of the function, opening and closing brackets, opening and closing curly braces. This is the body of your function. This is where you do everything that you need to do. And then you need to call your function for it to actually do what it's supposed to do. So now the idea of having now to have input values within your application. So what it does is, or within your function, sorry. So now here we have this calculate function, and inside it we want to have parameters. And parameters that we will just have the parameters of each unit and what it pays. So here we get unit 1, unit 2, and then this is an integer. And I told you there's times where you need to explicitly declare the type of data that you want, and this is one of them. When you're not ready to give it an initial value, when you're just calling it for now. So here, when you're using it in functions as parameters, you can have them as you can just tell them, I'm going to store an integer in this place. So here, unit 1, unit 2, return an int, and then unit 3 supposed to be unit 1, sorry, unit 2, and unit 3. Maybe you just have 3 units and return an int. Yeah, so that works. And then what you need to do, provided you have given them parameters, you can have something. So for now, let's just work on the printing. And what it does is it says total amount is equals to, create a variable that says variable total amount is equals to unit 1 plus, just copy paste this, unit 2 plus unit 3. So this changes to 2 and this changes to 3. And then here, when you're calling it, you're going to call total amount, and then you're going to write total amount. You're going to close it. And then you're going now to call your function, which is going to be calculate rent. Now, initially, when you're calling your function, you are just writing calculate rent. But now, because it takes in values, so parameters are just values that your function takes in. Because it takes in values, you have to actually write those values. So let's just say here is 20,000. We have one paying 30,000. We have another one paying 40,000. So now what happens is when you're calling your function is calculate rent of unit 1, which is 20,000, unit 2, which is 30,000, and unit 30,000. So when you run
Print
this,
out the total amount of the rent that was calculated at this case. So now we can move to the idea of learning about return types. And return types is making your work simplified. So instead of using the variable tenant is equals to unit plus 1 plus 2, what you do is you just have a return keyword, and the return, what it does is it just returns the computation, which is unit 1 plus unit 2 plus unit 3. And now the difference when calling our function when using a return type, you have to call it in you can call it within a print line. You cannot call it on its own because inside it there is nothing that is being printed on the console. So for you to actually see it being printed on the console, you can use it within a print line function. And now when you're calling it, use the dollar sign, and in this case we have just print line, and then print me the function of the computation of this function that has these values or these parameters. It takes these parameters, so 20, 58, and 40. And now as you can see, it actually prints the total amount of the total amount of our rent based on the parameters that we entered. Another thing you need to notice is that you can always change the values. So maybe sometimes you can find that instead of paying 20, your tenants were paying 20,000, 50,000, 40,000. So when you change, all what it does is your function will calculate the actual value and will take in the parameter that you've stated for it to take. Please don't forget to like, subscribe, and share where you feel like you learned something and you want to introduce somebody else to the channel. I have also put certain links on the description, just directing you to the different individual lessons that I had previously taught. And if you want, you can compare and contrast and see where you gained more knowledge or where you had more clarification. If you have any questions or you need more clarification on a specific topic, please go ahead and just leave a comment. Tell me what you want me to clarify on, and I'll be here. I'll respond to your comments. Please go ahead and comment, and I will respond to your comments. So don't forget to like, share, subscribe, and just bring a friend and tell me what you need to learn more. So in our next lesson, we'll be doing classes and objects. I hope you're ready for that, and see you then. Au revoir.